Hi, this is a quick video to show off what I've been working on. I don't know what I'm going to call this for real, but right now I'm calling it Better Shaders. If people have suggestions for names, I'm always open, pretty much open to suggestions on anything. So what I wanted to do with this project is fix a bunch of things. Ideally, what I want is a simple way to write lit shaders, not wacky, shaders that are post-processing shaders or things like that. Just I want to be able to write lit shaders without having to deal with lighting. If you've ever opened up the compile or the output of a shader graph for like HDRP, you'll find like a 9 to 12,000 line shader for something that just draws a color. And that's got a lot of it abstracted away and stuff too. So it's very hard to write lit shaders with no documentation for the render pipelines and no real template to work from. And the pipelines are very complex. Like the HDRP pipeline has like 12 or 14 passes or something like that. So you really have to understand a lot of code to just make a very minor thing. So I want to fix that, and I want to do it in the way that Surface Shaders did for Unity. They made it very easy to write a simple shader. You could just focus on the shading and not really think about lighting too much, and it would just handle that. Not that they didn't have their own set of problems, but I'm hoping to fix some of those too. I want the shaders to just work across all three pipelines, right? So I don't care whether I'm on or Universal Rendering Pipeline, HDRP, or Standard. I want to be able to write something that's going to output some normals and some specular data and albedo, and just have it just work. It should just load into any pipeline. It should act like a normal shader. I shouldn't have to do anything special. I should be able to use it just like a normal shader. And I want people to be able to distribute these shaders as finalized work. I don't want them to have to buy my shader authoring tool just to use the shader. It'd be nice if they bought it, but the thing here is that there are a lot of asset developers out there who are putting in a lot of work to port shaders between different systems, fighting with the various tools. This tool can let them write the shader once and have it work for all three pipelines. It would be nice if they can install and it just works for anybody, and they don't need to download a third-party package to make it work or anything like that. And they don't have to like unzip things and replace things and see pink shaders when it first comes about. And I'd like to improve the modularity of shaders. And this is for both developers and users. So shaders, when you start getting into very large shader systems, you start tying all kinds of code and properties and C buffers and all this data together, and you end up with this giant thing. And if you abstract it right, you have all these different include files, but it's not really flexible for developers in a lot of ways. Like, for instance, if you're making snow, you can't just include that snow into your shader and have it just work. You actually have to instrument your shader with its properties, its C buffer entries, etc. And then you have to, make sure to get all the right data to it and then call the function in it. And that works fine for small stuff. But as things grow, it becomes really harder to manage. And additionally, users have a big problem here, which is that they buy some shader on the store and then they buy some other system that does weather. And they're like, well, how do I get the snow on my trees? Because, the shader I bought doesn't have snow, or maybe it has a different form of snow and so it doesn't match the snow on the ground. And you end up with this kind of fragmented problem space that requires a lot of work to pull everything together. So for users, it would be nice if they can combine things and be like, you know what, I'm just going to buy this snow package. I'm going to add that to all my shaders and it's just going to work. And I think this would open up new markets to solve these old problems, right? We've all seen these various shader packages on the store, and they do some percentage of the stuff we want to do, but not all of it. And so I don't think it's going to solve everything, but I think it will help with this problem. So enough of the PowerPoint. I'm going to switch over to Unity, and I'm going to show you some stuff. So this is a little test scene I put together, and essentially it's got a bunch of shaders here. The first one is just kind of like a standard shader. right? So it's got an albedo with some UV scales and offsets. It's got a tint, normal map strength. It's got, a pack map for holding the specular components. That's kind of the I think they call it a mask map in HDRP. I'll get the namings matched up, but it's packed like in the format they use. And options to use emission map and detail texturing and all that kind of stuff. So you can turn on and off these options, edit all the parameters, everything just, works as you would expect it to. So you can see like I can tint or whatever. Let's look at how that shader is written first. In the Better Shaders package here, I'm going to go in Examples. I'm going to go into our basic here and look at the standard shader here. This right here is, this is the whole shader. So it looks, if you've looked at a surface shader, it looks very similar. You basically have a options block, which is where you can set things that would have been set in the pragma defines, things like alpha, if you want tessellation on, stuff like that. And then there's a begin properties block that just has all your properties in it. It's basically the same as the surface shader, just that you have these begin end blocks instead of brackets. And then you have a C buffer area. If you've never written shaders outside of the surface shader system, the C buffer might be new to you. It's a constant buffer, and it's basically just a way that the CPU can upload a whole collection of properties at once, which is good for batching and things like that. So you put your stuff, you just put your non-texture properties in here, and they all get uploaded at once, which makes the CPU faster. And on HDRP and URP, this is basically how everything is done. And then you have this defines block where you can define things in here like shader feature local. Great, I've got a couple different features here for these different features you can turn on and off. And you'll notice in the properties block here, I'm just using the standard material stuff. What's funny is that I've been writing custom material editors for so long that I was really tempted to write a lot of like nice editor attributes and things, but then these shaders would not look as good when they shipped without my packaging. So I'm trying to keep that separate. And then in here, I have all my code under this begin and end code block. And you can see here, I've got a blending function for the detail normal. I've got my samplers declared here. And then I have this surface function. And the surface function is, you basically get lighting inputs, and you get, which is what you fill out. It's the inputs to the lighting equation. I thought about calling this like surface data or something, but that term has been used all over the existing code. So I decided to just call it what it is, which is inputs to the lighting equation. And so that's your albedo normal. It's basically like the surface functions you see in the regular shaders. My cat has gotten into something. Get out of there. That's basically the lit shader or standard shader in a nutshell. It's about 2 pages of code, about 110 lines. This would be about, if you built the same thing in the shader graph, it'd probably be about 14,000 lines and would only work in HDRP. So this is much simpler to work with. I'll just show some other stuff really quick here. Here's a tessellation example. I basically set the shader name to be tessellation example, and I turn on tessellation. I set it to distance. There's different types. And again, I add my properties and C buffer stuff. And then I have a modified vertex function. This is basically if you want to change the vertex in the vertex shader part of it when we're setting up the vertice. So if you were packing stuff into the texture coordinates and stuff, you could extract them here and do whatever you need to do with them, or change the root vertex position. And then you have a modified tessellated vertex function. And so that gives you your standard, like, hey, I want to displace this vertex that's been generated type stuff. And then you have a function to get the distance factors, which right now I've just hard-coded on this shader to basically fade the tessellation from 0 to 35 meters and has a max of 12 subdivisions. You could make properties for these and stick it up here, and it would all work. And then I have a basic surface function, which is just basically sampling the normal and the albedo map. So again, syntax is really simple. And there's a nice thing here, which is that you can right-click, create a new shader, and then under this, there's some examples, but there's also one that's full. It's called a documented shader. And so if you open this one up, it's, oops, that must have been the min one. Did I select the wrong one? Let's try that again. Create shader. I might have something wrong in the code there, creating the wrong one. Yes, I do. Well, I will fix that, but I will show you the shader anyway because it's just stored in a template. Get rid of that. And then in shader template, documented. Here we go. And let's not open it in that. Nobody wants to see stuff in that. There we go. Let's try a different font. There we go. So I'll fix that little bug. It's pretty simple. But what this will do is it'll generate a shader with all the options laid out for you. So you can see in the begin options block, here's some of the options I have right now. We have like alpha or not. You can set the path and name to the shader, tessellation. You can override the tags if you want to change the geometry, sort order, stuff like that. Your properties block, your C buffer block, the defines block that we talked about. And then in the begin code section here, it's got a lot of comments to show you what all the parameters are. So the vertex data that you get passed in the tessellation and modify vertex functions, that's essentially what it has on it. And what it actually does is if you don't use some of these things, it'll strip them. So if you don't use text chord 3 or you don't use vertex color, it's going to strip them automatically. As soon as you type that variable name, it's going to include that into the structure. So these are kind of like smart structures that get optimized. Lighting inputs, you have albedo, normal, smoothness, metallic, occlusion, emission, and alpha. I think I'm going to add height to there because it's so often used. Even though it's not really an input to the lighting, it's something that you kind of want to have around when you're surfacing. And then I have the surface data here, which is basically just a bunch of stuff that's pre-computed for you if you use it. So if you use it, then you'll have world space position there for you. Same for any of the text chords, screen UVs, screen position, and then there's the all-important TBN matrix for converting between world space and tangent space. And so yeah, when you get one of these shader data objects in one of your functions, you need the world space position, you can just grab it from there. Pretty simple. And then I have some stuff subbed out here that I have not finished about final color, which is, if you know the surface shader terminology, that's basically like after you've done lighting, you can adjust the color. So if you want to do custom fog or whatever, you can do it in there. I still have to figure out how that's going to work with all the different pipelines, but that's basically the format explained for you. So if you've gotten through all that, let's show some cool stuff off. First of all, let's load this in HDRP. And up comes our HDRP project, and you can see that we have the same scene just magically working in that with the exact same shaders. You got your tessellation and all the fancy features. Now, the next thing I'm going to show off is modularity of shaders. I really think that when you write very large shaders, it becomes sort of hard to manage, and it's hard for people who are using your shaders to combine them with other shaders. And so I wanted to make that better. So here I have that standard shader again. And again, you can see, here are the controls for it. And then I wrote another shader which just puts snow on an object. And it basically has an albedo and a normal and a snow amount that I can adjust. Yeah, so it's I could take this much further, give it much nicer snow, but it's completely independent. And then I have a thing here called a stack shader, and you can just create these from the shader menu. If we go to better shader, you can see that there's a stacked shader option here. And all this stack shader does is when you click on it, it has this little list of shaders here. It has a standard shader and it has that no stackable shader. Okay? And so you just drag those in there. And now it's going to apply the standard shader. And then it's going to pass the result of that to the snow stackable shader. And what you get is you get a stacked shader like this one. So this shader, it's combined the properties in the C buffer from those two shaders, and it's chained the code together such that one shader finishes, calls the next shader, and we can apply layered shaders. So for instance, you could build a vertex painting pipeline this way, where you just have a shader that looks at a single channel and does whatever it does. And then you could be like, you know what, I'm going to use this layer, and then I'm going to use a wet list layer for the next one, and then I'm going to apply a snow layer, and then I'd be able to paint each one of those, or whatever you want to do. You could apply a moss shader using the same technique, and then apply a snow shader on top of it. And the format for doing this is exactly the same as the regular shader format. So here I have this stackable snow shader. If I open that guy up, you can see it has its own properties, right, for the snow. And that's all it is. And its surface function just does the snow. And by putting it in this stack, it will just chain those shaders together. And it'll chain this together for most of the functions. So if you want to have each one modify the vertices, you can do that. If you want to have modify the tessellated vertices, you can do that. And it will just call one after the other. And right now there's a limit of 10 in a stack, but that could be raised if people found this really interesting. I'm trying to, as I'm doing these kind of experiments, I'm trying to figure out the right balance of all this stuff. Because for instance, on that standard shader I did, there's no reason I could not have made that shader from stacking a shader and then doing a detail texturing shader, and then an emissive shader on top of that, and then you can build it out of these parts. But to me, it's really about what are the users going to want, and that seems more like effects. So, I want to add snow. I want to add grunge to something. I want to add some noise function that's based on world space to randomly vary this thing, or, create these types of modifications to it. And the other thing I'm experimenting with is a way to pass data between these structures that's safe. And there's already ways to do it, but more formal ways. And this kind of opens up new doors for shading and modularity. I can take this same snow shader. I can take a shader that's built for doing trees, and I can stack them, and now I got snow on my trees, right? So it's very, very cool. The shaders do have to be built in my system to do this. I can't just do it with an arbitrary shader. But once you're in my system and you're writing shaders this way, you get portability across the pipelines. You get these types of cool features, being able to stack things. And I think for large projects, this can actually make the system much better, because you can develop each of these independently and then have them combined, in whichever way the artist wants, without having to program them. If they wanted wetness on top of this, they could do that. If they wanted wetness to happen before the snow, they could do that. They can control the layering of these things. So I'm pretty excited about this concept. I'm a little scared of it too, but I'm pretty excited about the idea that you can just take these fragments of shaders that people have written and combine them in various ways without even needing to know how to program. However, for the programmer who wants to use include files, I want to show off an example here, which is that I have a really simple base shader here for normal and albedo. And then, actually, let me go back to that. Let me show you that first. So this base shader here has, in this begin includes block, includes this subshader. And a subshader, that's just a name I chose for it, but it's a shader which the system isn't going to try to compile as its own shader. It's like a traditional CG Ink file. And the difference though between this and a normal CG ink is if you just wanted to bring in a CG ink, you could put that in your begin defines block, right? Begin and defines block. You can put just whatever you want, suck in normal includes. This include is only for my system, and it works a little different in that if we go back here and I look at the actual file it's bringing in, this is actually bringing in the properties, defines, and in this case there aren't any. Oh, I do have some raw parameters. These should be in a C buffer, otherwise we won't batch. So that's a little bug I need to fix there. But I brought in some parameters here and some textures and brought that into my main shader without my main shader having to know too much about it. It doesn't have to know what properties are in this file. It doesn't have to know, about the C buffer elements and stuff. It's more than just the code that gets brought in. And then if we go back to that base file here, we'll see that this actually checks a define and then calls the snow. And if we look at that, I should have just left them both open, huh? If we look at that snow file, you can see it's setting the define, and then this will actually call it. And that's just a little safety thing. So if you later took out this include, everything would still compile. You don't have to do that. You could call the function directly. So yeah, that's an example of basically increasing the modularity for programmers where you're not, you just want to like keep your properties and code together instead of having them. What happens in a normal shader is that these property blocks and C buffers get everything from every include put into it. And so if you're trying to like grab somebody's code, you have to actually know all the things that it needs to have in its properties and stuff like that. So that prevents you from having to worry about that. The final thing that I want to talk about is distributing these. So if somebody has this installed, they can just use one of these really simple shader files, right? They can just be like, okay, here's my alpha shader. That's all they need. It's going to compile it into whatever platform they're on. If they change, versions of HDRP and both versions are supported, it would just upgrade the shader automatically. It works just like you really want it to. But a lot of people, I talked to a lot of other asset store developers about this, and they're looking for solutions to distribute shaders and solve their shader problems. It's a big problem in the store. And the problem with that is that they can't really be like, well, I need everybody to go buy this other asset to handle my shader compatibility. So I would love if this became standard enough that, everyone just had this installed and we could all just ship the simple versions, right? And certainly if you want to edit, that's what you want to do. If you want to allow editing. But not everybody is going to have whatever this costs to spend on that. So I wanted something that would work for them. And what I have is a system which isn't actually in the HDRP project right now. So let me get out of here. Go back to the standard one. I have this system called the shader packager. Okay. And what this does is you basically create, where did I put it? Shader package. Here you go. Create a shader package. Let's give this guy a name. We call it like, my shaders, whatever. And then here, what you can do is you can create entries for different shaders. So you can basically say, hey, I want to ship this shader, and it doesn't matter what system created it. It can be an ASE shader, it can be from whatever, but I want it to be on versions, Unity version 2019.3 to 2019.4. I'm going to include whatever shader it is for HDRP, right? So you basically like put all these in, and then you pack this object. And what it will do is it will store these all inside this scriptable import object that we have. And then there's a little bit of code that you would namespace into your own. You basically, let me just not worry about that for now. You basically copy these two files into your project. Sorry, these three here. And you would put them in your own namespace. And essentially, then you would be able to ship your shaders as one file. And when somebody installs your asset, it will extract the compatible shader that you've provided and turn itself into what looks like a shader, right? And if they upgrade their pipeline, if it has a version that works for that version, then it will install that one. And so then the materials don't break. You come into the scene, everything looks like it's supposed to, regardless of which pipeline you're on. So, and you don't have to ask your users to unzip the right package for the right pipeline, and then you don't get the support, questions about that, or unzipped and this didn't work. Yeah, it'll just work, right? And so I'm going to open source this. And again, it doesn't matter which shader system. If you want to handwrite shaders and use this just to pack them up and distribute them and have them automatically select the right shaders, that works. If you want to use ASE to generate one shader and then want to do the HDRP one in the shader graph and do the standard one in mine, whatever you want to do, it'll just work. Oh, and then one more thing I should show is how you get shaders out of my system. So if I select any of these shaders, like I select the standard one that I made, I can actually choose the pipeline I want to export it for. I can say, great, export the HDRP version or the standard version, and I can hit export shader and it will write out the code here. And then here you'll see what the real code to that shader looks like, right? Which is on the standard pipeline, it's 2,200 lines of code versus 100. And if I were to export that for, grab it again, for HDRP, export. Here we see the HDRP shader, which is going to be really long. It's only 5,300 lines. But compared to 100 lines of code, it's a lot more manageable. So yeah, and this is all super alpha right now, so it's all going to get UI improvements and stuff. But to go back to those goals, right? So we want a simple way to write lit shaders. I think writing 100 lines of code to get the standard lit shader versus 5,000 is pretty good. And if you work with surface shaders, it will feel right at home to you. And I've already done stuff to macro foo the difference. So if you type a standard that's in the surface shader, like the way that you can sample textures with different samplers, or if you do Unity world to object, it will actually, when it gets to the HDRP pipeline, it'll actually convert that for you. So it'll accept the surface shader syntax for things. And these just work across the pipelines. I can load them in any of the three pipelines and they will just load up and everything is great. And we have a way to distribute this work. It's if you're distributing using my system, using the my format, then they're going to just work in a really wonderful way. If you're using just the packer, then it's up to you to provide all of the versions of the shaders that you want. But to the user, it feels like it's one shader, right? And the materials don't break and things don't need upgrading. They just work. So that I'm going to open source because, hey, that's a cool thing to do, and I think it'll make the experience for asset developers and particularly for users who are new to the render pipelines much better than it is right now, where you install things and you get a bunch of pig things and then you go into support and you find out, oh, there's a package I need to unzip and then I need to run the shader like material upgrader or whatever. Like all that goes away. It just works. And finally, I do think that improving this modular kind of workflow and both for the developers and for the users is really important. I feel like being able to develop a piece of code that you bring in and call a function on, but it brings its properties and stuff with it is a lot easier, takes a lot less time to integrate something if I'm doing it on the code side. And then if you write your stuff to be modularized, then there's lots of things that can be done by stacking shaders together. And users can build up their own shaders and decide what features they want from what packages, and they don't have to be written by the same person. I don't have to write the same snow as someone else. If you like their snow better, you can put it into my shader, right? And if you don't have snow for the shader that you're writing, or don't know how to write snow, or don't know how to write wetness, or any of these things, you can just grab the chunk that I've written and just throw it on your shader and make a new one. And so you don't have to solve everything yourself. You don't have to manage the complexity of a massive Uber shader. Something like Microsplat is thousands and thousands of lines of very deep, complex code. And this breaks it down so that we can solve these problems more individually. It's not going to work in every possible case of like this stuff, but it lets us like treat our systems more separate and then have the user decide how they want them combined. And I think that'll open up new markets. Like, I'm really excited by the idea of producing some packs for this, where there's just some like really cool, effects that you can add, weathering for objects, weather effects. I can think of a bunch of things that can be done like this. And, and that's just cool. And if other people come up with stuff, or if you're managing a studio, it means you can like haul these things onto the next game, or you can write just the module that does, like I worked on a game once that had a vertex distortion effect, and we needed it in all of our shaders. Well, now you can just add it to the shaders you bought off the store, right? Like if they're done in this system. And more so, we can pull those to the next project and have all these effects available, and we don't have to manage modifying some mega shader because, it needs this one little thing different. So now we got to go in and like change the entire, code base, right? So that's really exciting to me, and I hope that it means that a lot of people will be interested in this system. I also think that long term, it'd be really cool to integrate things like this with graphs, where these types of modular shaders can be built. So, if somebody wants to make a graph, use a graph to make, the snow module or whichever thing they're coming up with, they can. And as long as it could output to this format, then, it'd be pretty easy to have all this stuff just kind of work. So yeah, that's where I am. Like I said, it's very early. I guess for the last thing I'll do is maybe load this up on URP, since I haven't done that yet. I loaded it on HDRP, but here we go. Here's the URP version. And here we go. Now we're in URP. And again, Tessellation, alpha, all of it just working super simply. Shader stacks, loads up, boom, it's all there, right? That's what you want. So, yeah, I'm pretty excited about this. I hope you guys are too. And if you have thoughts, I'm always looking for the things that, the use cases that people have, and trying to figure out the best ways to do that within the system. I'm not going to cover everything. There's a lot of things. If you handwrite a shader like that, there's a lot of things you can do that maybe won't be easy to put into this. But I do think this solves a lot of problems in an elegant way, and I'm pretty excited about it. Thanks for watching.